Hello, everybody, and welcome to the Microsoft Data and AI South Florida user group. My name is Adriano, your host, and thank you for joining us for another amazing presentation here with Thimantha today. Please let us know whether you can hear us and you're able to see us well. Drop it in the message section. Also, let us know where are you located. As I mentioned, I am in South Florida, so let us know where you're at. So without further ado, let's keep going. So today we'll be talking about Microsoft Fabric, workspaces, and strategies, limitations, configurations, and a lot more. This all brought to you by Thimantha. So we're going to have the navigating the limits of Microsoft Fabric Workspace. Now, if you have any questions during the presentation, use the live chat and enter your questions. Remember to like, subscribe, and share. So without further ado, here we have Thimantha. Hello, Thimantha.
Hello, Adriano. How are you? How is everything?
Well, thank you. Thanks for being here and with
Oh,
us. And share your time and your knowledge.
absolutely. You should.
Yes, coming up
Oh,
right
yeah.
away.
No worries.
All right.
All right. Firstly, thank you so much, Adriano, for this opportunity. Happy to be here, speaking at the Microsoft Data and AI South Florida as always. Um, Firstly, good morning, good afternoon, and good evening to everyone who had probably joined us from around the world. This session today is navigating the 1,000 item limit in Fabric Workspaces, a data engineer's perspective. Um, as you may probably know, Microsoft introduced a 1,000 item limitation for Fabric Workspaces around April this year, and this session is completely about how can a data engineer approach or manage with this manage like simply how can a data engineer approach this 1,000 item limitation. Um, Without further ado, a little bit about me for anyone who doesn't know me. I'm Thimantha. I'm currently working as a data engineer at Amos, which is one of the biggest pension funds here in Canada. And apart from that, I also have some certifications under me. And the most recent certification is the Fabric Analytics Engineer certification. And leaving everything aside, I love contributing to the community, data community as well. So I'm a part of the leadership team at the Toronto Data Professionals community. And a little bit about the Toronto Data Professionals community. This is one of the largest data communities here in Canada, and we do have monthly online sessions that we consistently have every month. And also, there is the one big event for us every year as well. So the big event is nothing other than SQL Saturday Toronto. So this year we have SQL Saturday Toronto on 25th of October at Microsoft headquarters Toronto, and you can simply scan through the QR code and um, get more details about SQL Saturday Toronto as well. And if you are someone living around Toronto, feel free to join us, and feel free to join the community as well. Moving back to today's topic. Firstly, let's get ourselves looking into the agenda related to today's topic. Firstly, we'll get ourselves into a basic introduction to this 1,000 item limitation, and um, simply what do you simply the very basics of it, like starting with what is a fabric item. And next up, what we'll head towards the perspectives that a data engineer should consider for this 1,000 item limitation. And finally, we would wrap up this session with the conclusion. Now, as I mentioned in the agenda, firstly, we should take a few minutes to understand what is a fabric item before getting into the 1,000 item limitation in fabric, right? Now, a fabric item is nothing other than any data related artifact that you create or build within a fabric workspace. Now, this could be a data pipeline, it could be a notebook, it could be a data warehouse, it could be a lakehouse, it could be a SQL database, it could simply be any artifact that you build within a fabric workspace. A fabric workspace, and that is what you call a fabric item. Now, the limitation is completely set on this fabric items, right? You can only have 1,000 of these items in a single fabric workspace, right? The limitation cannot exceed 1,000, right? Now, what does that mean for us, right? Um, in terms of a data engineer's perspective, a data engineer should have strategical have a approach to strategically handle this 1,000 item fabric limitation, because if not, with the time, as the time goes by, there would be definitely a significant growth in the fabric items, and you are definitely going to hit the limitation. So it's important for us to strategically approach this 1,000 fabric item limitation, and to look at it from the strategic perspective, right? Now, what are these strategic perspectives that a data engineer should look at? Firstly, a data engineer should look at it from the workspaces perspective. How to manage this 1,000 item limitation from the workspace then, right? Then also a data engineer should look at this from the data storage perspective. How can we manage the 1,000 item limitation with respect to data storage? How would we manage the data storage to accommodate that 1,000 item limitation in a fabric workspace, right? And finally, a data engineer should always should look at it from the ETL or the ELT perspective. Now, what is that? ETL, and this has everything related to data movement, data orchestration, transformations, cleansing. So everything related to that needs to be looked at in terms of addressing this 1,000 and managing this 1,000 item limitation as well, right? So we'll look at each of these perspectives in details, and let's look at how can we actually strategically approach uh, the 1,000 item limitation as a data engineer in these three different perspectives, right? So firstly, starting from the fabric workspaces perspective, right? Or the workspaces perspective. Now, managing the fabric workspaces is completely reliant on the workspace segregation, or you call it the workspace separation. How do you separate the workspaces and how do you organize your workspaces? Before even we get to that stage, what we need to understand is that any kind of solution that you build in Fabric, it could be a large scale or small scale, medium scale, you name it, right? It should follow the basic practice of having a development workspace and a production workspace, right? So whatever you build and uh, create should be happen within that development workspace. And what's eventually going to happen is that whatever that's built there, if it's all good, you deploy it to the production workspace, right? Minimum, you need to have these two workspaces when you're building any kind of solution, or when you're building any kind of uh, any kind of solution within Fabric, right? Also, you can add the optional UAT workspace into this, right? So how does it work with the UAT workspace? So simply you do the development in the development workspace. Then afterwards, you deploy it to the UAT workspace for testing, right? Now, after you test everything in the UAT workspace and after you're happy with that final product or the final solution that you came up with, what you do is you deploy that solution into the production workspace, right? So with this workspace segregate so with Fabric workspaces, you need to follow this strategy. You need to um, follow this concept at the minimum, at least at the minimum level for anything that you build within Fabric, right? But this does not have any impact on the 1,000 item limitation, right? This is a best practice, right? Now, as I mentioned, the 1,000 item limitation is only what it simply says is you can only have 1,000 Fabric items in a single workspace, right? Now, when you have these environment related workspaces, dev, UAT, and production, what would eventually happen is like all these environments are going to have replicated Fabric items, right? For example, something you build in the dev workspace is eventually going to be deployed or eventually going to replicate in your UAT workspace. And if it's all good in the UAT workspace, that is going to replicate in the production workspace. So what does that say? It does not have any impact on the 1,000 item limitation. But when we are approaching workspace segregation or workspace separation for the 1,000 item limitation, we have to always have this basic it uh, that separation should completely happen based on this basic best practice, right? um, so what does that specifically mean? Like you would get it when I get into the next slide and start talking a little bit about the different ways of segregating these workspaces. Now, we can segregate workspaces by teams or departments, right? Now, what does that mean? So as you can see, um, we have, as per the example in the screen, we do have development workspace for the sales team or the sales department, and they have their own UAT workspace, and also they have their own prod workspace, right? For the finance department or the finance team, it's a same process, right? You have a development workspace, you have a UAT workspace, and have a production workspace, right? So you can see that best practice of having a development to production or development to UAT to production workspaces is incorporated when you're segregating the workspaces, right? So that is something you need to keep in mind to always have that environment level workspaces, right? So this is one way of segregating workspaces. Then also we can segregate the workspaces by project to initiative, right? So for example, for a particular project or an initiative, you can have a individual you can simply segregate all the Fabric items related to that project or initiative, right? Finally, you can also segregate the Fabric items based on the data sensitivity, right? You can simply have separate workspaces for sensitive data and non-sensitive data. For sensitive data, you would have its own Fabric items, and it would be in a separate workspace, right? For non-sensitive data, that they would be in a separate own uh, separate workspace with their own Fabric items, right? So what does that mean? So everything's not in a single workspace. So the Fabric items are segregated based on different workspaces. Now, if I just revisit the other approaches as well, it's a similar process, right? So, for example, the in this case, the Fabric items are segregated based on sales and finance, right? All the fabric items related to sales would be in that sales workspace, and all the fabric items related to finance would be in the finance workspace, right? And if you look at it uh, from the project initiative level, the process is the same, right? Or they would, uh, as I mentioned, all the fabric items related to the project would be in that uh, specific workspace, and all the fabric items related to an initiative would be in a separate workspace as well, so that all the fabric items wouldn't be residing in a single workspace, right? So that is why workspace segregation is important, so that you can segregate the fabric items within it to accommodate the 1,000 item limitation, right? Now that is simply that is simply the approach to manage workspaces to accommodate this 1,000 item limitation. But the segregation is, I must say, the segregation is not completely reliant on these options that I had mentioned, which is by um, team, department, data sensitivity, and also project and initiative. There are other options as well. One such popular option is the medallion architecture option. Now, what that does is a medallion architecture would have a bronze layer, would have a silver layer, and also would have a gold layer. Right now, for each layer, what is going to happen is that the artifacts related to, or the fabric items that are related to each layer would reside in a separate workspace. You would have a bronze workspace separately, you would have a silver workspace separately, and you would have a gold workspace separately. So that is another approach as well. But why I didn't include that in this deck is because that is more of a architecture level best practice, and that is not specifically related to this 1,000 fabric item limitation. But yes, that is definitely another option as well. Similarly, there are much more other options that you can explore to segregate your workspaces. But the whole point is that by me suggesting these options is that what you need to keep in mind is you would need to definitely segregate your workspaces at some level to ensure that you accommodate that 1,000 item limitation, right? So that is the whole point of this workspace segregation. Now, we talked about the workspaces as perspective number one. The second perspective, as for the slide deck, is data storage. How can a data engineer approach this from the data storage perspective? Now, as you might know, Fabric has so many data storage options. You have the lakehouse, you have the warehouse, event house, KQL database, SQL database. Now we have Cosmos DB as well. But just for the time constraint, just to accommodate this time constraint, I would only be sticking to the options, or I would only be sticking to the data storage perspective with respect to the lakehouse, right? Now, lakehouse is one of the most powerful data storage options that you have in Fabric. So I think this is a very good example. This would help you to get a good understanding of how to by sticking to the lakehouse, you would be able to get a good understanding of how to manage data storage to accommodate this 1,000 item limitation, right? Right. As usual, with respect to the lakehouse, we can segregate the lakehouse once again by different ways that you would like, right? You can segregate it by team and department. That is one approach. You can segregate it by project and initiative, or initiative. That is another approach, right? So there are much more other. You can also, as I mentioned, you can segregate the lake houses based on the medallion architecture as well. You can have a bronze lake house, you can have a silver lake house, you can have a gold lake house. So that is another option as well. So similarly, you have multiple options to segregate the lake houses. The whole point here, once again, is that you would need some level of lake house segregation in order to accommodate that 1,000 item limitation, and it might not be the best practice to have a single lakehouse works, but you should manage it in a way. But segregation is another option that you can think about as well to manage this 1,000 item limitation, right? So that is that. All right. Now, in terms of lake houses, something we need to keep in mind is we have a bunch of features with respect to lake houses. And firstly, what I'd like to cover here is the cross workspace data movement, right? Now, what does that mean, right? Now, cross workspace data movement means you can have a specific lake house residing somewhere, and you can have a pipeline that is residing in a completely different workspace, and you can use that pipeline to simply store data or to simply load data or simply to read the data from that particular lake house, right? Now, as for this example, it's a very simple example. You have a data source and you are simply extracting data from that data source with the use of a pipeline that is residing in workspace A. And what is eventually going to happen is that pipeline is going to load data into the lakehouse one that is residing in workspace B, right? I also have a demo with respect to this example. So let us actually quickly go into the demo front and take a look at this, right? Now, this is my Fabric workspace I'm using for most of the demos in this session. And so the pipeline I built for cross workspace data movement is this. As you can see, a very simple pipeline with just a single copy data activity. And what does it do? So keep in mind, we are currently in this Fabric temp sandbox workspace, and the pipeline is completely residing there. And what I'm doing here is I'm just getting some sample data, and I'm loading the data into a lake house that is residing in a completely different workspace, which is Fabric Temp Sandbox demo backup workspace, right? So I'm simply loading the data with the pipeline that is residing in a different workspace, and I'm loading the data into a lake house that is in a different workspace, right, with this particular pipeline. So that is pretty much the approach that we follow. That is pretty much cross workspace data movement in the most simplest form. Now, this is a feature that is available for lake houses and warehouses only at the moment, but as for the in terms of the future, this would be definitely be available in other options, in other storage options as well. But for now, this is available for lake houses and warehouses only. Now, with respect to that, so that is cross workspace data movement for you. Um, Simply moving data across workspaces, and you do need to keep simply the pipeline does not need to reside in that same lakehouse where you need to bring in the data. The lakehouse can reside elsewhere, and you can simply move the data with the use of the pipeline to that particular lakehouse residing in a different workspace. That is that. And next up, what I'd like to show you is another feature that you have in these lake houses, which is the shortcuts, right? Now, shortcuts is simply a form of data virtualization, right? Now, so shortcuts is primarily available for options like Amazon S3, Azure uh, data storage, Azure Data Lake Storage, for data storage options like Azure Data Lake Storage, and simply Amazon S3 is another option. So what does these shortcuts do, right? So what this does is the original table or the original data would still reside in the Azure Data Lake storage. Let's say would still reside in the data source. And what you do is you create a shortcut from that particular data source into your lakehouse. right? It could be a delta table that you might have in your Azure Data Lake storage. So what you do is you create a shortcut to simply for that delta table inside your lakehouse. So your data would still reside in your Azure Data Lake storage delta table, but you are just creating a shortcut that would provide you the data virtualization option. In other words, it would bring the metadata, only bring the metadata into your lakehouse, right? So that is simply shortcuts, right? Then also we have the option of database mirroring, right? So database mirroring is simply it would create a direct replica of a source database and it would simply bring it into a workspace, right? Now, this is a direct replica, and how is this maintained? This is completely maintained with the change data capture, right? So whenever there is a change in the source database, what is going to happen is that replica that's residing in the workspace is going to identify that change through the change data capture and it's going to bring that change into that mirrored database, so the replica of the database that is residing in the workspace, right? So that is another option to go in this case. Now, if I just take you through these three features once again, just to brief you before I go to the next stage, right? So you have the cross workspace data movement, which is simply moving data simply have simply um, moving data across workspaces. So let's say you have a lake house that is residing in workspace B, and then you have a pipeline that resides in workspace A. The data pipeline can simply extract data or read data from a particular data source and simply load it to the lake house residing in workspace B, right? This can happen. This is possible and this is supported for warehouses as well, right? And shortcut is nothing but a data virtualization technique, and it's supported for data sources such as Azure Data Lake Storage and Amazon S3. And what that would do is, for example, let's say the data source is the Azure Data Lake Storage, and you have a data delta table residing inside that Azure Data Lake Storage. You can create a shortcut of that delta table and you can simply bring it into your lake house. What that would do is it would only get the metadata of that delta table and bring it into your lake house, but the data would still reside in the data source, right? Then the final option is the database mirroring, which is simply what it does is it gets a direct replica of a source database and simply brings it to the workspace, right? So what this does is like this is completely managed by change data capture. What does that mean? So let's say the source, there are certain changes in the source database. With the use of change data capture, the changes would be identified by the mirrored database or the replica of the database that is residing in the workspace. And those changes would be incorporated to that workspace after that, right? So these are the three options. Now, how does something I didn't cover is how does these three options support the 1,000 item limitation, right? Now, cross workspace data movement, what does that mean? You don't need to have many lake houses, but you can have a single lake house, a central lake house that would move data across and across different workspaces, right? Now, this is the what would that do? That would reduce the the need to have lake houses in like every workspace or simply multiple workspaces, right? So you can reduce the number of lake houses by using this approach, and you can kind of maintain a central lake house strategy, where you have a single central lake house or multiple central lake houses that would be used for multiple purposes. So that is how the 1,000 item limitation is addressed with the cross workspace data movement. And when it comes to shortcuts, How it is addressed is with the use of so when you create shortcuts, you simply don't need any data pipelines or simply notebooks to bring the data from that particular data source into your Fabric lakehouse, right? Because with the shortcut, you are still keeping the data inside the data source and you are just bringing in the data, a metadata into the lakehouse, and you can still read the table and work with the table inside the lakehouse, right? So what does that mean? It cuts down the need for pipelines, stuff like pipelines, notebooks, and data flows that are needed to actually bring the data into the workspace of the lakehouse, right? So that cuts down the fabric items that are required in this case, right? Um, a similar benefit, you get a similar benefit with the database mirroring option as well, right? You don't need to specifically have a bunch of pipelines, data flows, or notebooks to simply get the data from that particular data source and to bring it and have it inside, bring it and have it inside the workspace or inside a lake house, let's say. Sorry, inside a workspace, right? By a single mirrored database instance, it gives you all the tables in that inside that workspace, right? You don't that would cut down once again the need for the pipelines, notebooks, data flows, and all the data orchestration and simply the data movement transformation options that you have in Fabric, right? So that's the benefit of these three features that you have um, respective to storage, right? So that is that. And next up, so firstly, we looked at the workspaces as a perspective. So primarily in terms of workspaces, what you need to do is workspace segregation or separation. You need to separate workspaces based on a particular strategy. It could be team, department, it could be sensitive, non-sensitive. It could also be um, uh, it could also be what do you call the medallion architecture, bronze, silver, gold. That is another option. So, and yes, and it could be project initiative. So that is how you would simply manage the workspaces for this 1,000 item limitation. Then, secondly, what we discussed was how do you manage the storage for this 1,000 item limitation. Now, specifically, we focused on this with respect to the lake house, right? Now, in the lake house, you can manage this with the use of the shortcuts and also with the cross data workspace data movement, which simply minimizes the need to have multiple lake houses everywhere. You can follow a central lake house strategy. You can have a set of central lake houses residing in particular workspaces, and you can reuse it for multiple purposes across workspaces, right? So that is the benefit of that. And finally, we covered database mirroring, that is related to data storage, but not related to lake houses. But what that does is it creates a replica of um, databases. Now, this is primarily supported for Azure SQL databases, and I think Snowflake as well. I'm not particularly sure, but it does and SQL Server databases, on-premise SQL Server, and yes, it does support a bunch of bunch of databases where you can actually create a replica in your workspace as an instance and simply use that without having pipelines or notebooks to bring that into your workspace, bring those data into the workspace. So that is simply how we can manage data storage. And next up, we'll focus primarily on the ETL or the ELT side of things, which is nothing but data orchestration, data movement, data transformations, and data cleansing. Right now, with respect to that, Fabric has primarily has data pipelines, notebooks, and data flow Gen 2 to cater this ETL, ELT functionalities. Right, but in this session, we would solely focus on the data pipelines and notebooks when we are with respect to this 1,000 item limitation, right? Now, Firstly, let's start with the data pipelines, right? um a usual technique that we would use, that you, if you had previously used Azure Data Factory, you Azure Synapse, or any other tool previously, is a technique that we use is pipeline parameterization, right? So what does that mean? Let me quickly show the demo that I have here. I do have a very basic example with a very basic demo to help you understand this. And what this simply does is, this is my okay. This is my example or the demo that I have for pipeline parameterization. Now let's take a look at what it does. Right now, this is a single pipeline, and this actually operates in a way where if you want to override the data in your destination table, you can simply do that by passing a value to the parameter, right? And let's say you don't want to overwrite, you want to append the data in your destination table without overwriting. You can still do that with the same pipeline by passing a different parameter value. And as you can see, I have a single parameter that is called is overwrite in this case, right? Now, what does this do? Right? The moment I pass a value, particularly if I pass um, is override yes or is override no, it would identify if an overwrite operation should happen or an append operation should happen, and it would simply do that operation accordingly, do action accordingly to that destination table. Now let's take a look at how closer look at how does this happen. Right now, firstly, I have a parameter file. Now in this case, my parameter file is a simple CSV file, but also you can use stuff like JSON extracts for this. So what it does is it gets my list of tables and tables, and with the action that is related to each of these tables. Right now, what this does is, and then also on the other hand, I have a variable to capture the value that is coming in, capture and simply do the need and assign a value based on the value that is coming in from my pipeline parameter, right? Let's say I simply say is override yes. What's going to do is, in this variable, the yes is going to be identified, and the variable, I think it's load type, is going, that is in this activity, the load type, which is a variable, is going to be the value for that variable is going to be assigned as override. Right now, let's say I pass is override no. What is going to happen is, the value that's going to be assigned to this variable is going to be append. Right then, based on that, you are filtering out this table list. Right now, this is a usual process that we all follow in data factory, Synapse, or any other tool as well. Right then, what you do is, you simply cut down, simply you filter out your table list from, based on this variable that is assigned, the variable value that is assigned, and then you pass it into the for each loop. Right now, in the for each loop, what is happening? Right, so I'm getting the values or getting the records that I'm getting from that parameter CSV parameter file, and I'm going to assign it accordingly. For example, I want to, so in this case, what I'm doing is I'm getting a copy from one lake house and I'm copying it to another lake house. So the table name remains the same. So I'm getting this from the field table that is coming from the parameter file. And in terms of the destination side of things, what I'm doing is I'm passing the table name, and I'm also passing the action that I'm getting from that parameter file, right? And I'm simply performing that operation according to the value that is coming in from the file that you see here. So this is pipeline parameterization in the most basic and the simplest form that I could explain. Now, what what benefit or what how does this accommodate the 1,000 item limitation? If you recall, back in time, we had a process that if when we are building any data engineering pipelines, we had to have a historical load or one-time load pipeline separately and an incremental load pipeline separately, right? So what happens is, like, one-time load would simply bring in all the historical data into your data warehouse or your environment. Uh, um, and simply the incremental load is the run pipeline that would run in daily basis to capture data incrementally, right? For that, you had two pipelines earlier. Now, with an approach like this, you can manage multiple things with a single pipeline by just changing the values in that parameter file, right? And also changing a bit of logic if required as well. But if you just change the action that you're passing from the parameter, and also the values that are coming in from the parameter file, you can simply accommodate all that with a single pipeline, right? So that is the benefit of pipeline parameterization here, right? Pipeline parameterization, right? Now, the purpose of that is to minimize the number of pipelines, which would accommodate the 1,000 item limitation. Now, another example for this is, now that was pipeline parameterization, right? Now, secondly, what I'd like to show you is another technique that we could use to minimize the number of pipelines, right? Now, as you might know, if you are already using Azure Data Factory or Synapse, you might follow the practice of having invoked pipelines, right? So what does that mean? You might have separate pipelines to perform separate actions, and at the end you would have something called a master pipeline that would invoke those separate pipelines into a single streamlined pipeline, and that would be the pipeline that you would be running, right? Now, when you use the pipeline invoking techniques and when you have multiple pipelines and when you invoke them, what does that mean? That eventually means you are increasing the number of pipelines that is going to hit the 1,000 item limitation, right? That is going to contribute to the 1,000 item limitation, right? But what if we can follow an approach like this example, right? Now, as for this example, you have a master data pipeline, right? And you have a invoke pipeline activity that is related referring to a different pipeline that simply does the ingestion. Now, ingestion. This is an ingestion pipeline. Now, in the ingestion pipeline, you have a copy data activity that would simply ingest the data, right? Then also, after the ingestion, you would do the transformation and loading, right? For that, let's say you have a separate pipeline that has a notebook in it with a notebook activity. And what you do is simply the notebook is going to run and do the transformations and load the data as required, right? Now, in this approach, we have three pipelines, right? Master data pipeline, ingestion pipeline, transformation and loading pipeline, right? Ingestion and the transformation and loading pipelines are invoked into the master data pipeline, right? Now, what if, so instead of following an approach like this, what if we cut down the invoke pipelines? What if we try to minimize the number of pipelines? What if we bring that copy data activity in that ingestion pipeline directly into the master pipeline? And what if we bring that notebook activity directly into that master pipeline? In this case, what you would do is, instead of having three pipelines, you can have two pipelines. Now, what I need to stress here is that it might not be simple. This is a very simple example to understand how you can minimize the invoking pipelines. But that does not mean it's practically simple as this, right? There can be very complex situations where you have a complicated amount of pipeline activities that are useful, that simply doesn't help you, or that would make uh, minimizing pipeline invokes very challenging, right? But this is an approach that you can try to do, which would eventually minimize the number of pipelines, right? Now, how simply the whole purpose of this is to minimize the number of pipelines, right? So, and in minimizing the number of invoke pipelines would eventually mean that you are minimizing the number of pipelines because you are bringing the activities or the operations that are having those in those invoked pipelines into another pipeline or master pipeline in this case, right? So that is one strategy that you can explore to make it work, right? That does not mean it's very straightforward. That does not mean it's simple as it looks in this example. The purpose of this example is to let you know, yes, there is an option like this that you can think about as well, right? So that is the benefit of that, right? And another bonus segment of this pipelines in terms of managing uh, well, typically pipeline execution, right, is by variable libraries. Now, keep in mind the purpose of variable libraries is primarily to accommodate deployment, right? Now, what is a variable library simply? It's simply a container, or you can say a component in Fabric, in a Fabric workspace that would store a list of variables, right? And you can have the different value sets for that variable, and you can switch between those value sets as per how you want to execute a pipeline, right? Now this is primarily used for purposes in deployment such as connection strings, right? For example, if you are deploying from a dev to production workspace, your connection string that you are connecting to some sort of a dev data source can be different to the connection string that you are trying to use for the prod data source. So what you do is you can facilitate some, simply adopt something like a variable library that would have the connection string for the prod data source and the dev data source, and it can switch by a single click based on the environment that the pipeline is currently running on, right? But these variable, even though that is the primary purpose of it, these variable libraries can also act as an alternative for pipeline parameterization, right? You can simply pass values to your pipelines through these variables, and simply you can control the way you execute the pipeline, control the execution of the pipeline. If it's in the as per the previous example, we considered we control the pipeline based on the load type, right? Whether it's a full load, or whether it's going to be a whether it's going to be a overwrite load, or whether it's going to be a append load. Similarly, by passing those similar values through a variable library, what you can do is you can control these pipelines more as well, right? So that is another option that we can explore to minimize the 1,000 item limitation. Now I know a variable library itself is a Fabric item, and it can eventually plus one to that 1,000 item limitation. But how we could think about is that how does it add value to execute your pipelines by minimizing the number of pipelines? How does it add value in minimizing the number of pipelines is something we could look at with these variable libraries, right? That is simply that front. Now, we looked at the pipeline front, primarily pipeline parameterization, and also we looked at in minimizing the pipeline invokes, and also we discussed a little bit about the variable libraries. Now, next up, let us move into the notebooks, right? Now, notebook parameterization is very identical to the pipeline parameterization. Now, I'm not going to waste time explain everything from scratch, as you have some understanding of how this particular parameterized pipeline works. Now, what if the same applies for parameterizing a notebook, right? Now, let's say you want to load data into a destination. It could be an append or an override, but simply that varies depending on the value that you pass to the pipeline, right? So what do you do eventually, right? So you pass these actions, or simply pass if you want to do an override or an append into that notebook as a base parameter. And within the notebook, if I just open the notebook here, what it would do is it would capture that action into a variable and into a parameter, and simply pass that to perform the kind of write that you want to do for the um, particular destination table. So this is the destination table, and as you can see, the action that is coming in as a base parameter here is going to be performed here in the right. So that is a very simple example of notebook parameterization. Once again, what benefit does that add, right? What value does that add? You don't need to have multiple notebooks for different types of writes or anything. You can completely control that by passing notebook parameters and having maintaining a single notebook, right? Now you would understand this point a little further once I get into my next and the final demo, right? This is notebooks using conditional logic. Now this is a standalone notebook, but let me show you a little bit to inspire you on how does that how does that even work, right? So this is the notebook, and if I just take you to this notebook, now let me explain this from scratch in terms of how does it work, right? Now I have a bunch of parameters that I pass. Firstly, you have the table name and action, right? So table name is the name of the table that you would like to copy. Let's say like copy, transform, or load from a particular destination, from a particular source into a particular destination. Action is simply what you how do you want to load the data into the destination. Do you want to load it as an override, or do you want to load it as an append, right? Then also I had brought in some other parameters that gives me control over the transformations that I do, right? Now let's say I want to add a transformation query, a SQL query, to read the table from that particular source in a particular with a particular logic, and to copy it, right? I can pass it with a separate variable as well, right? Then also let's say, okay, let's say you don't want to use a transformation query, you can simply say no and move further. And let's say you want to select the columns that you want to write into that destination table. You get that option as well as separate variables. You can say enable select columns as a separate parameter in this case. And also the columns that you want to select can be specified in a separate parameter in this case, right? Now, how does it work? Now, in this case, the source is simply my, yeah, let me just take you to that source. Um, right. So everything's residing in this single lake house, right? Source is simply um, so sources from this for this demo purposes, the sources coming from this tables in the lake house itself, and the destination for the destination, I'm just copying it into a writing it into a separate table with the underscore transform, right? Just for this demo purpose, right? So what I'm eventually doing is I'm reading the source table with the use of a SQL query if I want, like let's say a SQL query. And then what I'm doing is I'm writing it into the transform table. Now I can pass, just say, well, let's say I have a SQL query to like read it and write it into the destination table. I can say provide transformation SQL query as is. And what that would do is it would reach this if condition and it would read the table based on the SQL query, and then it would write it into this destination based on the parameters. Right now, let's say I don't want to pass anything for the transformation query. So what does that mean? If I pass no, that means it's going to completely neglect this condition, right? So then it's going to get into the second condition, right? So like sorry uh, not the second. It's simply if I pass no, it's simply going to get into this condition. And let's say sorry, a second condition, and it's going to check. I'm sorry. So if I say no here, what's going to do is it's going to neglect this first condition, and next up it's going to get into the second condition. Now in the second condition, what it's going to happen is it's going to check if the enable select columns is set to yes. If it is set to yes, what are you going to do? Right. So it's going to select the columns that you had specified in the next parameter, and it's simply going to assign that into the data frame. And that data frame is going to be copied into that destination. Right. Now, let's say that you say no, pass no to both of these, and the table is custom and you want to do an override. What would that do? Right now, in the if condition, it would look at the first condition, it's going to neglect that. Second condition, it's going to neglect that. But when it comes to the third condition, where the provide transformations equal query is no, and the enable select columns is no, what's eventually going to happen is it's going to do a select all to that lake house table, and it's going to copy it, write it into a separate transform table as an override that you pass it. Right now, previously you might have yeah, to accommodate a situation like this at some point in your career, you might have used multiple notebooks for this, right? Because logic is too expensive, and simply it is much more comforting to use multiple notebooks for this. But with that, with by following a conditional logic approach like this, we can manage multiple different logics, and we can do multiple I mean, we can accommodate multiple different logics by passing and controlling everything with the use of the parameters, right? So in this case, rather than me having 2 to 3 notebooks, I manage everything in a single notebook to control what I read, how I read it, and also how I write and what I write, right? So that complete control, I got that complete control over by the different parameters that I pass in. All right. So that simply accommodates the reduction of the number of notebooks that you use. Right. So that is, with that said, that is a wrap of my session, and I would like to conclude with this the final well like I would like to conclude this session by saying the perspectives for data engineer to consider in terms of the 1,000 item limitation is these perspectives lie on the workspace level, data storage level, and the ETL ELT level. And there is no particular fixed strategy saying, okay, this is the route that you need to follow to accommodate the 1,000 item limitation. It is completely based on a case-to-case basis, right? It's completely based on your situation, your workload, the security that's required, data growth. I can go on with the list until the end of day today. Like it's it has different like it has different aspects or different considerations that you need to have in place to actually decide what is the strategy you need to have in hand to manage that 1,000 item limitation. And that is simply what I wanted to show in this session, is to inspire you in terms of how to, as a data engineer, how can you manage this 1,000 item limitation? Like, what are the options that you have in hand? All right. So, with that said, that is a wrap for my session. And if you'd like to connect with me on LinkedIn, you can use the QR code that you see in the screen right now and connect with me on LinkedIn. And if you have any questions, you may go ahead with it right now, or if you would want to reach out to me individually in LinkedIn, feel free to do that as well. Um, with that said, thank you so much, Adriano, for having me as always. It's a privilege for me to be here and speak in your data community, and looking forward for more to for more opportunities to speak with you guys as well. So thank you so much, Adriano, for this opportunity. Thanks.
Thank you very much as well, Thimantha, for making the time to be here, sharing the great knowledge here with us. So, folks, remember, got a question? Enter your question right now on the live chat. If you're watching this presentation with us, if the presentation has completed, use the comment section below, and we will follow up with you on your questions. Now, as Thimantha said, look at what he covered. This was quite an insightful presentation talking about Microsoft Fabric workspace strategies. These are based on real world experience and also on practical information. So I hope that this can assist you all on your journey here with Microsoft Fabric, how to improve, optimize your existing environment. If you already have one, if you don't have, it helps you to strategize how to best implement your next workspace. He talked about different aspects. You recall storage, workloads, and we are talking about including parameterized workloads. I'm sorry, data pipelines. In addition to uh, load strategies that we just saw there, different ways to approach. So you can avoid the 1000 limitation, 1000 items limitation in Microsoft Fabric Workspace. So I hope this has really helped you improve yourself and your environment. So remember to like, comment, and subscribe to the channel. Also, if I recall correctly, Thimantha, you have a SQL Saturday coming up in Toronto.
That is correct.
Can you share? Do you still have that screen there,
That
please?
is correct. Let me get back to my screen. So simply, we have SQL Saturday coming up
Mhm.
on the sorry about this one.
And in the meantime, folks, remember, use the chat right now to enter your questions, and we will follow up here.
Right. Yes. So as Adriano mentioned, we have SQL Saturday coming up on the 25th of October. So please, if you are living around Toronto, feel free to join us and join the community as well. And yeah, it's going to be a big day. So yes, feel free to join us. Thank you so much.
Excellent. Very exciting there. So let me take a look here. I see we do have viewers, but we do not have any questions
Mhm.
at this point. All right. So without further ado, I'd like to say thank you, everyone, for making the time to be here with us. Stay tuned because we have another presentation coming up. We will be posting in a day or two. Most important, do not forget this presentation. Take your time, review, replay. If you have questions, you know where to go. You can drop in the comment section below. And we'll follow up with Thimantha, or you can reach out to him as well. All right, Thimantha. Thank you again. Appreciate it for being here, sharing the knowledge. Any last words?
Not really. Thank you so much for everyone for listening in. And if you do have any questions, feel free to reach out to me. And thank you so much, Adriano, for having me in. Happy to be here as always. Thank you so much.
Thank you. Happy to be here as well. Folks,